so I took a few weeks off to work on another more important project, so I'll ease back into this now that it's finished. I have a two-parter episode on models and animations also in the works, but for now I want to focus on a more simple topic. Today I want to talk about game objects, and how I plan to structure all the things that are drawn to the screen in my game. In a game we have a bunch of different objects that the player can interact with vastly different results and abilities. For example, we can have a door, quite simple. When the player activates a door, it should open if it's closed, and close if it's open. However, this functionality gets quite complex when you have to program it. Let's take another object, say a chest. When activated, it should open an inventory screen, and maybe animate to open. Now both the door and chest share a bunch of information, such as they both have a 3D position in the level, they both have a model that needs to be loaded into the GPU, and they both have animation. If we make a chest object, we would have to duplicate all the information from the door object, and then also into a chair object, a light object, a barrel object, you get the idea. Now in programming, we use a technique called inheritance that allows us to define an object and then create a bunch of sub-objects that have extra data associated with only that object, while still getting all their properties from this parent object. So that's what I have, a simple object with a bunch of data that everything needs, model paths, 3D position, animation states, and those sort of things. Then I create a bunch of sub-objects for each new type I want. However, there is still a problem. In my levels there are doors. Now all these doors look and act the same, except that they are placed in different positions. Now I could make a copy of the door for every instance of it in the level, but this is very wasteful since I would have 10 copies of the same door loaded into the memory, for example. To solve this, we define reference objects and base objects. Base object stores all the information that is shared among all instances of the object, the model data, animations, name, etc. Then, reference objects are used for every instance of the object within the level. These contain the 3D position, animation timestamps, and activation states. In order for everything to be able to reference everything else, every object created, be it a base object or a reference, is given a unique ID that can be used to look them up. For example, I create my wooden door base object and store its ID. I then create 5 reference objects to this door which are placed throughout the level, and each is given the ID of that base wooden door. When it comes to rendering, where I'm working through all the reference objects in the level, this ID can be used to look up the wooden door object and grab the model data. Obviously there are a bunch of optimizations going on in the code, but this is the general idea of the system. Every reference can also be given a unique name in order to allow them to be affected by a future scripting language I want to develop. So in the future, if I write a line that says on level load open boss door, then when the level loads, the door reference with that name would be open. The reason we have these names instead of just using the ID number of the door is that the IDs are really hard to remember and it would make the code look really confusing. In a simple scripting language, we want something that is reasonable to understand when you're just reading it in English. Combining this reference-based system with the parent sub-object system from before, it allows for process names to be shared between all the objects. So I can ask the chest to activate and it'll run an animation and show an inventory screen. If I ask the door to activate, then it can figure out what state it's in and whether to open or close. Each sub-object reference can share the names for things it can do, but then carry that task out differently. This is really good for a future scripting language again, as it simplifies the number of commands for the objects. It also makes programming the interaction much easier, as every object can handle what it does itself. That's all for this week. Next up will be a two-parter about models and animation, and the first of them should be up next week. Thanks for watching.